London, 1851. British engineers gather around an American plow at the Crystal Palace and burst into laughter at the crude steel blade hammered together by a frontier blacksmith. European iron plows had been perfected over centuries, they declared, and this contraption would break in a season. Within 10 years, those same engineers would be reverse engineering that plow in secret, desperate to understand why their farmers were crossing the Atlantic to buy it. The cast iron gospel. For 3 centuries, European plowmakers had worshipped at the altar of cast iron. The material had been perfected through generations of metallurgical refinement. British foundries in Sheffield and Birmingham produced plowshares so precisely cast that they became the global standard. The moldboard curves were mathematically calculated. The share angles were optimized through decades of field testing. The weight distribution was balanced to perfection. This was not arrogance. This was earned confidence built on actual superiority. When a Scottish farmer bought a Ransom's plow from Ipswich, he was purchasing an instrument that represented 200 years of accumulated knowledge. The iron was hard enough to hold an edge through an entire season. The casting process allowed for complex curves that turned soil with minimal draft. The replacement parts were standardized and readily available. European agricultural societies held competitions where plow designs were judged like fine art. Engineers presented papers on moldboard geometry. Universities studied the physics of soil displacement. The plow had evolved from a crude tool into a sophisticated machine that embodied industrial excellence. Steel, in contrast, was considered fundamentally unsuitable for plow construction. It was too soft to hold an edge. It would wear down too quickly in abrasive soil. The manufacturing process was expensive and inconsistent. Cast iron could be poured into molds by the hundreds. Steel had to be forged individually, hammered into shape by skilled craftsmen. The economics made no sense. British plow manufacturers exported their products across Europe, to the colonies, to South America. Wherever soil needed turning, British iron plows dominated. The industry employed thousands of workers in the Midlands. The technology was mature, proven, and profitable. The Americans, struggling to establish agriculture in their vast interior, naturally looked to Europe for guidance. They imported British plows by the shipload. They hired European plowmakers to establish foundries in New York and Philadelphia. They tried to replicate European success using European methods, but the prairie had other ideas. The American problem. The problem revealed itself the moment European plows hit Midwestern soil. The black earth of Illinois and Iowa was unlike anything European farmers had encountered. It was not the light, sandy loam of East Anglia or the chalky soil of the French plains. This was heavy, sticky, clay-rich dirt, formed from thousands of years of decomposing prairie grass. It was fertile beyond measure. It was also impossible to plow with European equipment. The cast iron shares would cut into the soil beautifully on the first pass. Then the trouble started. The wet, heavy earth would stick to the polished iron surface. Within minutes, the moldboard was caked with mud. The plow dragged through the field like an anchor, forcing farmers to stop every few yards to scrape the blade clean with a wooden paddle. The mathematics were brutal. A farmer with a good team of oxen might plow half an acre per day if he was lucky and willing to destroy his body, stopping and scraping every 30 feet. Most managed less. The constant stopping exhausted both man and animal. The scraped blade would dull quickly from the abrasive friction, requiring frequent sharpening or replacement. European plowmakers responded with helpful suggestions that revealed how little they understood the problem. They recommended polishing the iron to a higher sheen. They adjusted the moldboard angles. They modified the share designs. Nothing worked. The prairie soil was not behaving according to European soil physics. Farmers tried desperate adaptations. They plowed only in dry conditions, but the Midwest weather was unpredictable. They used larger teams of oxen, but that just meant more animals to feed and more capital tied up in livestock. They switched to horse teams, which were faster, but required even more careful timing, since horses tired more quickly than oxen. The situation created an artificial ceiling on American agricultural expansion. The Midwest had millions of acres of the most fertile soil on the planet. But if you could only plow half an acre per day, that fertility was theoretical. European settlers were arriving by the thousands, claiming land under the Homestead Act. But claiming land and farming it productively were two different problems. Local blacksmiths experimented with modifications. They tried coating the iron with tallow or grease to reduce sticking. They welded additional iron plates to change the surface texture. They built lighter plows that required less draft force. Every innovation failed to solve the fundamental issue. Cast iron and prairie soil were simply incompatible. The economic impact rippled through the young nation's agricultural economy. Wheat prices remained high because production was limited by plowing capacity rather than land availability. Settlers who had traveled west with dreams of prosperity found themselves trapped by a technology problem that nobody seemed capable of solving. This was the world John Deere inherited when he arrived in Grand Detour, Illinois in 1836. A world where European certainty had collided with American reality and shattered into pieces. The Blacksmith's Rebellion. John Deere was not a farmer. He was a blacksmith from Vermont, trained in the traditional Eastern methods, skilled at making and repairing the tools that farmers needed. When he arrived in Grand Detour, he was just another craftsman trying to establish a business in a frontier community. He had no grand ambitions to revolutionize agriculture. He just wanted to fix plows. But Deere possessed something that separated him from the European engineers who designed plows in distant factories. He talked to the farmers who actually used them. He listened to their complaints as they brought their mud-caked implements in for the third time that month. He watched them scrape the blades with wooden paddles, cursing the soil that refused to cooperate with civilized technology. The breakthrough came from observation rather than theory. Deere noticed that the farmers' shovels and spades would self-clean after cutting through the sticky prairie soil. The smooth steel surface did not allow the mud to adhere the way cast iron did. Steel had a fundamental property that everyone had overlooked because they were so focused on edge retention and durability. The conventional wisdom said steel was too soft for plow construction. But what if softness was not the problem? What if the self-scouring property was more important than hardness? What if European plowmakers had optimized for the wrong variable? Deere obtained a broken steel saw blade from a local sawmill. Steel saw blades were made from high-quality crucible steel, harder and more consistent than the iron most blacksmiths worked with. He heated the blade in his forge and hammered it into the rough shape of a plow mold board. The process was crude, nothing like the precision casting of British foundries. But precision was not the goal. The goal was testing a hypothesis. The first test plow weighed considerably less than a cast iron equivalent. The steel was thinner because it did not need the mass to prevent breaking. The mold board curve was approximate, shaped by eye and hammer rather than calculated engineering. It looked like what it was, an experiment built in a frontier workshop with salvage materials. Deere convinced a local farmer to test it in his field. The farmer, desperate enough to try anything, hitched his team and drove the blade into the black earth. The plow cut cleanly through the soil. The dirt slid up the mold board and fell away without sticking. After 50 feet, the farmer stopped and examined the blade. It was still clean. After 100 feet, still clean. After a full pass across the field, the steel gleamed as if it had just been polished. The farmer wanted to buy the plow immediately. Deere explained it was just a prototype, not for sale. The farmer offered to pay double whatever Deere thought it was worth. Word spread through Grand Detour within days. By the end of the week, Deere had orders for 10 more plows. The self-scouring principle was elegant in its simplicity. The polished steel surface combined with the proper mold board angle created a situation where soil could not gain. Purchase. As the plow moved forward, the friction was insufficient to allow mud to build up. The blade cleaned itself continuously through the act of plowing. This changed everything about the economics of prairie farming. A farmer with a Deere plow could work from dawn to dusk without stopping to scrape. He could plow in conditions that would have been impossible with cast iron. He could cover 3 or 4 acres per day instead of half an acre. The productivity increase was not incremental. It was revolutionary. Deere began manufacturing plows in earnest by 1838. He imported sheets of steel from England, ironic given that he was undermining British plow dominance, and shaped them in his shop. Each plow was still individually forged, but Deere developed techniques to speed production while maintaining the critical self-scouring surface. By 1847, Deere had moved his operation to Moline, Illinois, where he could access both the Mississippi River for shipping and the industrial capacity to scale production. He was manufacturing 1,000 plows per year. Every single one found a buyer within days of completion. The American Midwest was being unlocked not by European technology, but by a blacksmith who would listen to farmers and questioned assumptions. But Dare understood that proving his plow worked in Illinois was different from proving it could succeed in the world. The ultimate test would come when he took his crude American steel blade to Europe and confronted the establishment that had perfected the iron plow over 3 centuries, the Atlantic Gambit. The decision to exhibit at the Great Exhibition of 1851 was audacious, bordering on foolish. The Crystal Palace in London was designed to showcase the industrial might of the British Empire and the technological sophistication of European manufacturing. This was where the world's leading engineers and industrialists would gather to demonstrate their achievements. American exhibitors were generally viewed as provincial curiosities, interesting for their raw materials, but hardly serious competitors in manufactured goods. Deere's partners questioned the expense. Shipping a steel plow across the Atlantic was not cheap. The exhibition fees were substantial. The time required for Deere or a representative to travel to London and manage the display would take him away from the business during the critical spring planting season. What was the point? American farmers were already buying every plow they could produce. Why court rejection from Europeans who had made clear their disdain for American manufacturing? But Deere saw something his partners missed. The European market was vastly larger than the American Midwest. Britain alone had millions of acres under cultivation. Add France, Germany, and the rest of the continent, and the potential market dwarfed anything America could offer. More importantly, European farmers were experiencing their own soil challenges. The heavy clay soils of England's Midlands, the dense earth of the German plains, these were not identical to Illinois prairie, but they shared the tendency to stick to iron plows. If the steel plow could solve European problems the way it had solved American ones, Deere would not just be selling plows. He would be establishing American agricultural equipment as a legitimate competitor to European dominance. That was worth the risk. The plow that made the journey to London in 1851 was a production model, not a specially prepared exhibition piece. Deere deliberately chose to show Europeans exactly what American farmers were using in their fields. The steel moldboard showed the hammer marks from forging. The wooden beam was plain American oak, not exotic hardwood. The whole assembly had the functional aesthetic of a tool built to work rather than impress. This decision would be interpreted as either bold honesty or confirmation of American crudeness, depending on who was judging. The British manufacturers who displayed their wares at the Crystal Palace brought plows that looked like precision instruments. The casting was flawless. The finish was immaculate. The components fit together with the tolerances of watchmaking. Deere's plow looked like it had been made in a barn, because effectively, it had been. The Crystal Palace humiliation. The Great Exhibition opened on May 1, 1851, in a building that itself represented European engineering superiority. The Crystal Palace was a cathedral of glass and iron, a structure that seemed to defy gravity through the application of mathematical principles and industrial precision. Over 6 million visitors would pass through its halls during the exhibition's 5-month run, marveling at the achievements of the industrial age. The American section was relegated to a less prominent location within the palace, a decision that reflected the general European attitude toward American manufacturing. The United States was recognized for its raw materials, its cotton and timber and minerals, but manufactured goods? Europeans remained skeptical that American industry could match their own standards of quality and sophistication. British plow manufacturers gathered around Deere's exhibit with the casual confidence of experts examining a student's work. They lifted the plow, assessing its weight. They ran their hands over the steel moldboard, feeling the hammer marks. They examined the joints and fittings with the critical eye of men who knew exactly how plows should be constructed. Then the commentary began. The criticisms were delivered with the polite condescension that British engineers had perfected into an art form. The steel was too soft. Any farmer using this plow in real field conditions would wear through the blade in a single season. The forge construction was inefficient and inconsistent. Cast iron could be molded to precise specifications. Steel hammered by a blacksmith would vary from plow to plow, making replacement parts impossible to standardize. The weight was wrong. Deere had built a lighter plow because steel allowed for thinner construction while maintaining strength. The British experts explained that weight was necessary for proper penetration and stability. A light plow would skip over hard ground or deflect when hitting rocks. The American clearly did not understand the physics of draft and soil resistance. The finish was crude. The steel showed tool marks and imperfections. A properly made plow should have a smooth, uniform surface achieved through careful casting and finishing. This looked like something assembled in haste from scrap materials, which, the British noted with barely concealed amusement, was apparently exactly what it was. French engineers were more diplomatic, but equally dismissive. They acknowledged that the self-scouring principle was interesting in theory, but theory was not practice. They had centuries of experience proving that cast iron was the superior material for plow construction. The surface could be polished to a high gloss that would resist soil adhesion just as effectively as steel. The American solution to a problem that proper ironworking had already solved. German manufacturers focused on the economic argument. Steel was expensive compared to cast iron. The forging process required skilled labor and time. Even if the plow worked as advertised and they were skeptical, it could never compete on price with efficiently cast iron implements. The American was trying to enter a market where he would be undersold by every established manufacturer. The agricultural press covering the exhibition reflected these expert opinions in their reports. The American plow was described as ingenious but impractical, interesting but inferior, novel but unsuited for serious farming. One British agricultural journal concluded that the Americans would do better to focus on what they did well, producing raw materials, and leave the manufacturing of sophisticated implements to those with the knowledge and experience to do it properly. Deere and his representatives endured this mockery with forced smiles and polite responses. They explained the sticky prairie soil. They described how cast iron plows would not work in American conditions. The Europeans nodded sympathetically and suggested that Americans should improve their soil rather than reinvent the plow. But Deere had not traveled across the Atlantic just to display his plow under glass. He had come to demonstrate it in actual field conditions, and he knew something the British engineers did not. European soil was about to betray everything they believed about their superior technology. The soil doesn't lie. The field demonstrations were arranged for after the formal exhibition, in the English countryside outside London. British plow manufacturers agreed to participate, confident that their implements would humiliate the American upstart in front of farmers who actually understood agriculture. Several major agricultural equipment makers brought their finest plows. Ransom's sent their latest model, the pride of Ipswich manufacturing. Hornsby brought a plow that had won awards at the Royal Agricultural Society shows. The field selected for the demonstration was heavy clay, the kind of soil that dominated much of England's most productive farmland. In dry conditions, it was hard as brick. In wet conditions, it became sticky and adhesive. This was soil that British plows had been designed to handle for generations. The local farmers who gathered to watch expected to see the American plow fail spectacularly. The British plows went first. A Ransom's implement was hitched to a team of heavy horses and driven into the field. The plow cut cleanly for the first pass, the iron share slicing through the clay with authority. The moldboard turned the soil in a neat furrow. The farmers nodded approvingly. This was how plowing should look. Then the soil began to stick. By the third pass, the operator had to stop and scrape mud from the moldboard. By the fifth pass, he was stopping every 100 feet. The clay was adhering to the polished iron exactly the way it adhered to iron plows in Illinois. The problem was not unique to American prairie soil. It was a fundamental incompatibility between cast iron and heavy wet clay regardless of continent. The Hornsby plow performed similarly. Clean cuts initially, then progressive buildup of mud until the operator spent more time scraping than plowing. The other British manufacturers produced the same results. Every single cast iron plow, despite their precision manufacturing and centuries of refinement, struggled with the sticky clay. Deere's steel plow was hitched to the same team of horses. The farmers watched skeptically as the lightweight American blade dropped into the earth. The plow cut through the clay and turned it in a furrow. The soil slid up the moldboard and fell away cleanly. After 100 feet, no scraping was needed. After a full pass across the field, the steel still gleamed. The operator drove the plow back and forth continuously while the British implements sat idle, their operators scraping mud. The contrast was undeniable. The crude American plow with its hammer marks and plain wooden beam was outperforming the finest products of British manufacturing. the farmers began asking questions. How much did the American plow cost? Could it be purchased in England? Would replacement shares be available? The questions had a desperate edge. These were men who had spent their entire lives fighting sticky clay with implements that required constant scraping. They were watching a solution to a problem they had accepted as unsolvable. The British manufacturers tried to dismiss the demonstration. The clay was unusually wet today. The conditions were not representative. With proper polishing, cast iron could achieve similar results. But the farmers were not listening to manufacturers anymore. They were watching the Deere plow continue to work while British plows sat motionless, caked with mud. More demonstrations followed in other regions. In the heavy soils of the Midlands, in the dense earth of Yorkshire, in the clay fields of Kent, the results were identical. The steel plow worked continuously while cast iron plows required constant cleaning. The self-scouring principle that European engineers had dismissed as unnecessary was proving to be revolutionary. Word spread through British farming communities faster than any advertising campaign could have achieved. Farmers talked to other farmers. Stories of the American plow that never needed scraping became almost mythical. Some claimed the steel was a secret American alloy. Others suggested it was treated with a special chemical. The reality was simpler, but no less remarkable. It was just steel, polished and shaped correctly. The begging begins. The first European orders arrived within weeks of the demonstrations. British farmers wrote directly to Deere's Moline factory, requesting plows and offering to pay shipping costs across the Atlantic. The letters had a tone that was new in transatlantic agricultural commerce. These were not curious inquiries about American novelties. They were desperate pleas from farmers who had seen a solution to their most frustrating daily problem. Deere faced a production crisis of the best kind. His factory was already running at capacity to serve American demand. Filling European orders would require either expanding production or choosing which customers to disappoint. He chose expansion, borrowing capital to add manufacturing capacity and hiring additional blacksmiths and workers. But the European market was not just about individual farmers placing orders. Agricultural equipment dealers in Britain began requesting the rights to distribute Deere plows. These were the same merchants who had been selling British cast iron implements for decades. They understood what the demonstrations had proven. Farmers would pay premium prices for equipment that actually solved their problems rather than equipment that looked elegant in an exhibition. British plow manufacturers watched this development with growing alarm. For the first time in living memory, European farmers were actively seeking American-made agricultural equipment. The natural order where Europe exported superior manufactured goods to primitive America was inverting. The crude colonials were competing successfully in the home market. The initial response from British manufacturers was to improve their own products. They experimented with polishing cast iron to a higher sheen. They modified moldboard angles. They tried new casting techniques. Some progress was made, but the fundamental limitation remained. Cast iron would always be more prone to soil adhesion than properly finished steel. The next response was to copy Deere's design. Several British manufacturers began producing steel plows, essentially reverse engineering the American implement. This created immediate patent questions. Deere had not filed for British patent protection, focusing his limited resources on the American market. The lack of patent protection meant British manufacturers were legally free to copy his design. But copying the design proved more difficult than expected. Forging steel moldboards required different skills than casting iron. The surface finish was critical, and achieving the proper polish required careful work that could not be rushed. British factories accustomed to pouring iron into molds found themselves retooling for a more labor-intensive process. The quality of early British steel plows was inconsistent. Some worked nearly as well as the American original. Others had surface imperfections that reduced the self-scouring effect. Farmers who had seen Deere plows in demonstrations were reluctant to trust British copies that might not perform as well. The preference for the original American product persisted even when British alternatives were available. French and German manufacturers faced the same challenges. They could see the design. They could measure the angles and dimensions, but reproducing the surface finish and the subtle curves that made the self-scouring effect work reliably required skills their factories had not developed. The simple steel plow that British engineers had mocked as crude turned out to be difficult to replicate properly. Deere's export business grew exponentially. By 1855, European orders represented a significant portion of the company's revenue. The factory in Moline was shipping plows across the Atlantic by the hundreds. The farmers who had begged to buy were now reordering, replacing their entire implement inventory with American steel. The industrial reversal. The export numbers told a story that humiliated European industrial pride. By 1860, John Deere and Company was shipping over 10,000 plows annually to Europe. British agricultural equipment manufacturers, who had once exported their products globally, were now importing American plows to meet domestic demand. The psychological impact was more significant than the economic numbers suggested. This was not just about plows. It was about the fundamental assumption that European manufacturing was inherently superior to American production. That assumption had been built on real advantages in skilled labor, established factories, and centuries of accumulated knowledge. But the steel plow proved that innovation could trump tradition, that solving the actual problem farmers faced was more important than following established manufacturing practices. The European manufacturers who did successfully transition to steel production had to acknowledge, however reluctantly, that the Americans had been right. Steel was the superior material for plow construction in heavy oils. The self-scouring principle was not a gimmick, but a fundamental improvement in agricultural efficiency. The crude appearance that had drawn mockery at the Crystal Palace reflected functional priorities rather than inferior craftsmanship. Patent battles erupted across Europe as manufacturers fought over who had the right to produce steel plows. Deere's lack of European patent protection meant the technology was theoretically open to anyone. But several European manufacturers had filed their own patents claiming improvements or variations on the steel plow design. The legal disputes revealed how valuable the American innovation had become. Companies were willing to spend years in court fighting for the right to produce implements they had dismissed as worthless crude 15 years earlier. The agricultural equipment industry in Britain and Europe underwent a painful restructuring. Manufacturers who refused to adopt steel production lost market share and eventually closed. Those who adapted successfully found themselves competing on American terms rather than European ones. The industry's center of innovation had shifted across the Atlantic. American agricultural equipment manufacturers used the success of the steel plow as proof that American engineering deserves serious respect. When they introduced other innovations like mechanical reapers, European farmers were more willing to give them a fair trial. The door that Deere had forced open with his steel moldboard allowed other American manufacturers to enter European markets. The success also changed how European engineers thought about American conditions. The sticky prairie soil that had seemed like a provincial problem unique to the Illinois frontier was now understood as representative of soil conditions that existed globally. American farmers had not been struggling with inferior land. They had been farming some of the most challenging soil in the world and developing solutions that worked anywhere. The unintended empire John Deere did not set out to build an industrial empire. He set out to solve a problem that frustrated farmers in Grand Detour, Illinois. But the solution to that local problem turned out to have global implications. By 1870, Deere & Company was manufacturing a full line of agricultural equipment, all built on the principle that American innovation could compete with European tradition. The steel plow became the foundation for an entire agricultural equipment industry that would make American manufacturers dominant globally. The farmers who had begged to buy Deere's plows in the 1850s created a market that would support American industrial expansion for generations. The technology that British engineers had mocked at the Crystal Palace became the standard against which all plows were measured. The psychological reversal was complete. European farmers now looked to America for agricultural innovation rather than the other way around. The industrial confidence that had made British engineers laugh at Deere's crude steel blade had been undermined by the simple fact that his crude blade worked better than their sophisticated casting. The legacy lives in every field where farmers plow without stopping to scrape, in the continuous movement of steel through soil, in the efficiency that makes modern agriculture possible. The American steel plow did not just win a market. It proved that the future belonged to those willing to question what everyone knew was true.